let's say y is equals to this, s is equals to h. Then you discover that m is equals to the m. All right, and let's look at graph. How to linearize a graph or an equation. Now, what I want to look at is this t is equals to 2 pi times the square root of L minus H over G. L minus H over what? Over G. Now, if I want to plot t square against h, what will be the slope of the graph and what will be the intercept of this graph? So look at how it's done. The first thing you do, you first of all linearize this equation here. How do you linearize equation? Remove all complexity. Ensure all terms are alone. They are not something like standing alone. You cannot define the term. Say this is the first term, this is the second term, this is the term here. All terms should be something like, and this h should be there, and t square should be seen in that place as well. In this place now, there's no t square. So for we to even have t square, we have to take the square of this side. So we are going to, because of space, for us to have this square, we are going to take the square of this side. They will also take the square of this other side. So that we'll be having t square is equals to, if you square to, what are you going to have? I'm going to have 4. If you square pi, you're going to have what? Pi square. If you take the square of a square root, this square will cancel the square root. Then I'm going to have L minus H over G. Then the next thing I'm going to do now, I'm going to open the bracket. I'm going to use this to multiply this L, also use this to multiply this H. The next thing I'm going to do now, and I'll be having something like this equal to, because of space, let me just rewrite it. I was having t square is equals to 4 pi square times L minus H over G. So that will give us this times L. I'm going to have 4 pi square L. Then we have minus here. The minus will still remain. 4 times 4 pi square times this. I'm going to have 4 pi square H. Then everything supposed to be everything over G. Then you will now say, you can also write this thing this way. You say this G over this and this same G over this. It's still possible since you are linearizing. So I'll just divide this one by that G. Also divide this one by that G. It's also done that way. It's also possible. Because if we want to take the same now, we just take G. Then we just run it. We still get back that stuff. So if you put t square here now, if you plot t square against h, so let me rewrite the answer out. I'm having, I hope we don't make mistake. I'm having t square is equals to 4 pi square L over G minus 4 pi square minus 4 pi square H over G. So I'm plotting t square against h. That's what I'm doing. That means t square should be in the y-axis, then h should be in the x-axis. So if I compare at the end of the day, okay, let's go. So since our h is the x-axis, if I compare this equation to this, something like this, y is equals to, let me just write it here. If I compare it to this, y is equals to mx plus c. See that the x-axis should be here. Although if the x-axis is still here, it's still correct, it's not too bad. So I want to bring this one to this side. I want to just interchange the terms. Then I'll be having something like this. T square is equals to, let me write this one first. Okay, minus, I'm going to have minus 4 pi squared h over g. Then this one now is plus. If there's no number here, if there's no sign here, it means it's plus. So plus 4 pi square L over g. So if you compare this equation now, so what we're having now, we're now having something like this. We're having t square is equals to minus 4 pi square minus 4 pi square h over g plus 4 pi square L over g. If I compare this equation to y is equals to mx plus c, y is called the vertical axis or the ordinate, while x is called the horizontal axis or the abscissa. So you take note of the spelling of abscissa and ordinate. Then if I compare this to this now, for this now I'm plotting y against x. For this part now I'm plotting t square against h. So if we run this, we are going to have something very nice. So this t square now is our y-axis, then h is our x. So I'm going to have y is equals to mx. Okay, let me just compare it like this. Let's say y is equals to this, s is equals to h. Then you discover that m is equals to, the m will be equal to 4 pi, that's minus 4 pi square over g. Then this intercept will be equal to this c. So the intercept will be 4 pi square L over g. That will be the intercept. So this is the intercept, while this is the slope of this graph. Then if they ask you what is the shape of the graph, the shape depends on what you are plotting. If you are plotting t square against h, the shape will be a straight line graph. Yeah, it will be a straight line graph. But if you are plotting t against h, to be a parabolic graph, since t is having a square, so you go to take the shape of a parabola like a quadratic equation. So that's how the thing is. If you are plotting t against L, as maybe you are plotting t against L, the slope will have been 4 pi square over g. Then this intercept will be 4 pi square h over g. So you take note of that. Yeah. Then if you are plotting h against, maybe if you want to plot h in the x-axis and y-axis and plot t square in the y-axis, I've already called what is called. For example, now let's say you are plotting t square against h. If you are plotting h against t square, what you have to do, you make his the solve formula. Then the coefficient of t squared will now becomes the slope. So that's how this stuff is. Taking note of that. It's very, very important. But the other side will be the intercept. Yeah. Thank you.